Hello pre-calculus students, this is Mr. McAllen and this is day 1 of section P1 in our textbook, and this is our first flipped classroom video. So I have a few examples. First of all, the objective of the lesson is to make sure that students are able to convert between decimals and fractions, write inequalities, apply basic properties of algebra, and work with exponents and scientific notation. So the first example we're going to do is an example where we talk about rational numbers versus irrational numbers. For example, if they ask you to identify if the numbers 3 over 16 or 20 over 27, 25 over 27 or 1 over 17 are rational or irrational, well, the answer is right away that they're rational because they are constructed using a ratio of integers. But here's the trick. A lot of people think that when you convert this on your calculator, that you're going to get some decimal string of numbers. So if the numbers are a ratio of integers, then it's rational. But if they're numbers that when you convert to a decimal, you see that the decimal terminates or repeats, you know that's also rational. Numbers like square root of 2, which will equal 1.414, and the pattern basically won't repeat or terminate, is called an irrational number. So here I took 3 over 16 and I did the division on my calculator, and the result was 0.1875, where the decimal terminated or stopped. The next one, 25 over 27, had a repeating pattern of 0.925, 0.925, 0.925, or we just represent it with the repeating bar. Try 1 over 17, and you will notice it is definitely rational, but it just takes, it's a much longer string of numbers to repeat. Moving along, we want to talk about interval notation. And one of the things we're going to do in class tomorrow is we're going to work with a whole variety of problems where we describe and graph an interval given by an inequality. So let's first describe this. This is saying x is less than the number 4. So the way we describe this on a graph is or on a number line is we would put on a number line the number 4, and we would draw a circle on it, and we would shade to the left indicating less than 4. But we have a fancy notation for interval notation. We would say this is also x is defined on the interval, and the interval would be, you have to put the I, the capital I in front of it, and you would do parenthesis, negative infinity, comma, 4, and you would do a parenthesis there. Now these parentheses mean that the interval is open, meaning not including that number. So notice we have a parenthesis here, so we're open on the left and we're open on the right. On the next one we're going to see something slightly different. We're going to see that when we depict this one, we have, well, let's describe it first. It says x is between the value negative 4 and 9, including 9. Okay, so in this case, we're going to have one interval that's open, and one side of the interval will be open and one will be closed. So we'll put negative 4 on the interval. Remember, this is a number line. We'll put 9, and we'll put a circle here and a circle here, but we'll fill in this circle because it's closed, and we'll fill in between, but we won't include 4 or negative 4. So in interval notation, we would write x, or I'm sorry, the interval from negative 4 up through 9, and notice I use a closed bracket. Now this means that that side of the interval is in fact closed, and this is open. So tomorrow, when we do some problems in class, we'll definitely be experiencing some different challenging problems by looking at either an inequality or looking at a graph of the interval. The next example is some properties that you should write down in your notes. So I'm going to pause the video here, and you should pause it as well, so that you could copy down some of these properties. So hopefully at this point you've had a chance to process these properties, or at least think about them, but the commutative property is just telling us the order of addition or the order of multiplication does not matter. Associative says that the order in which you add numbers, if you have three numbers to add, it does not matter, or the order in which you multiply numbers doesn't matter. The identity property is pretty basic. The inverse property says that when you add the inverse of a number to itself, you get 0, or you multiply by an inverse or the reciprocal, you get 1. And the distributive property is one of the ones that, as teachers, we really look forward to helping you out in terms of making sure that you use this property correctly. Well, so an example of us assessing whether you're doing the, just to say the distributive property, we want to write this expression in its expanded form. So that would just require distributing the x to both terms. So you would say the answer to that would be wx plus 3x. And then in the one below, we want to basically do the opposite of distributing, which would be just by factoring out the y. So you have 2 minus c multiplied by the value y. Our last example is just how we simplify expressions involving exponents. So what I want you to do is take a few minutes and write these down and try to compute what the answers are, and then I'll go over what the answers are in a couple minutes. So if you would pause the video and try, and then when you come back you'll see what the answers are. So now that we're back, just want to make sure the volume is working. Notice we've multiplied all the terms together. Remember, when we have, this is a the first power times a the second power, same base, you add the exponents. We have b squared times b the fourth, which makes b the sixth, and the 3 times the 6 makes 18. In this problem, the big deal is when you have a negative exponent, it basically tells you to take that base term and move it to the numerator or denominator, depending on where it is. If it starts in the numerator and has a negative power, you should move it to the denominator. And if it has a negative power in the denominator, you should move it to the top and change the sign of it. So we end up getting x to the fourth over x to the seventh. The last one, we're going to use a power of power rules. We're raising u squared to the negative fourth. That makes u to the negative eighth. We multiply powers in this case, not add them. And on the bottom, I made a mistake here because this squared, this 2 in the denominator should become 2 to the negative fourth power. And as a result, that's going to make 16 in the numerator, because 2 to the negative fourth would put 2 to the fourth up in the numerator, which would end up being 16 over u to the eighth. I hope this video has helped, and I look forward to make sure you answer the questions in the form, and I look forward to working with these problems with you tomorrow. Take care.